Hey, hi everyone. This is Manish. I'm part of Azure Cosmos DB engineering team. Welcome to my another show of Scalable AI in action. In this series, we talk about partner solutions which are using cutting edge agentic AIs or Gen AI and Cosmos DB around it. And every month we're doing this series, session. And in this month we have Tredence. I would like to welcome Unmesh. Hi, Unmesh.
Hello.
Unmesh is CTO, for AI and at Tredence. He's leading AI technology strategy, design and implementation. Unmesh works very closely with Microsoft Azure ecosystem and partners to deliver next gen AI solutions. He holds an MBA from Wharton and MS in computer science from IIT Kanpur. Welcome to the show, Unmesh.
Thank you, Manish. Excited to be here today. Glad to be with everyone. It's been a great pleasure for me and my team to work with very closely with Azure AI and Cosmos DB teams, and to join this session with you all today. Thank you.
Thanks. And without much, wait, we want let me straightforward take you to leadership as I chat. I have few questions to ask you. I hope you are ready.
Let's find out.
Awesome. So my first question is actually around the industry landscape. So looking at the current industry, landscape right now, what are the biggest challenges you see customers are facing today, and where do you see the most meaningful opportunities emerging?
Great question. So, for context, as the Senior Vice President of AI at Tredence, and Tredence is a specialist AI and data services implementation company, I get to lead a lot of strategic AI engagements with our leading customers and partners like Microsoft. And we work through a lot of large AI implementations, typically with Fortune 1000 companies. So it's actually a really good place to be in to see what are the industry trends, where is it going, what are the challenges, those kind of things. So with that context, it's a fantastic time today to be implementing AI projects, right, at scale. If you're building an AI agentic application or a platform, you today have a lot of extra capabilities. The number and quality of tools has improved a lot in the last 12 months. So you can actually deliver meaningful business value very rapidly today in terms of AI. Of course, that comes with a lot of challenges and opportunities, which I would broadly categorize into the standard parts, right? Processes, tools, and people. Let's start with the organization. The foremost challenge today for AI leaders is to find the right balance between the speed of delivery on one hand and governance on the other hand. The organizations are expecting rapid business value delivery, right, with co-pilots, with all of the AI models, but at the same time, the broader organizational readiness is not quite there. So governance frameworks are not in place, and the AI leaders are figuring out how to get the organization ready. Number two, the platforms and tools. That might sound funny because we just talked about innovation happening everywhere, right? But that is actually a problem because it's also very hard to make the right platform choices. How do you protect your existing investments, your existing infrastructure, but still set yourself up for rapid innovation? So if you have a cloud platform like Azure AI Foundry, you have a lot of SaaS applications, you have in-house, in-built applications. How do you integrate together is a fairly big challenge and also an opportunity. Finally, let's talk about the most important one in my mind, which is people and skills. And here, I think the bottleneck in delivery has fundamentally shifted, right? It's not coding anymore. It's not people writing, typing, testing code. It's the ability to specify the desired outcome. What is your product, your platform supposed to do? How would you validate the outcomes, right? The 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 blueprints, right? The proven patterns do not exist today for successfully specifying what a product should do, what it should be like, right? And the internal skills and expertise are not catching up yet. The external expert consultants often come in, solve a simpler version of the problem, and leave you to kind of solve the scale and accuracy issues involved. So that definitely for AI leaders is a big challenge. The opportunity kind of mirrors these challenges, but the reality is if you can actually bring these organizational roles, governance, process tools together, the opportunity is to deliver not 20, 25, 30% growth, but literally improve the productivity by 2x, 5x, 10x in your organizations. Manish?
Awesome. Uh,
The video is freezing up.
um, and then my next question is about your leadership journey. Uh, what mindset or decision-making principle have had the biggest impact on the driving transformation at scale?
Another good question. From my experience, the key attributes for leadership success in driving large transformation is just the ability to distill down a lot of things that are happening into things that matter, right? Separate the signal from the noise. Number one, where should I lead the organization? This is specifically critical in the time of big change like we are in today. Number two, what are the top three, four things that you need to focus on to make it happen, right? Not let a lot of day to day innovation, push and pull kind of distract you. Keep your sight firmly on your goal. And finally, probably the most important one again, how do I bring my org along for the journey? And this is particularly harder for people who actually come from engineering technical background into leadership positions, right? How do you understand that tech can be solved, but the success is about taking the users, the stakeholders along for this journey, right? And it starts with the board buy-in, the executive buy-in, and then enrolling the complete organization. So those are probably the key decision-making principles that can drive massive impact for a transformation project.
Awesome. And in your experience, as organization adopt newer technologies such as AI, data platform, and cloud, what are the most common misconception or pitfalls you have observed?
Oh, that's an interesting one because there are so many missions. It's hard to parse out the top three. It really varies organization by organization. I see a spectrum of like readiness, and they kind of create different kinds of pitfalls or challenges. There are some organizations which early on said no use of tools like ChatGPT or Copilots, and then there are others who kind of went head on and kind of probably experimented a lot. And now organizations have come back and said, look, I'm done with the POCs. I know what works, or I know what mistakes I've made. Let me actually kind of, activate the The three, maybe four big pitfalls. Number one is probably the missing importance of subject matter experts, right? How do you do the semantic modeling? How do you do the mapping of business and AI together? How do you do the right eval, right? The technical teams, the engineers are not going to create the knowledge graphs that truly reflect your business world without inputs from a subject matter expert. And you will see that in the example that we talk about later in we very closely collaborate with the subject matter experts who are actually involved in network rollout, for example, or in case of a banking, how do you actually detect fraud and those kind of examples. To bring it together, the AI engineers are not able to write the optimal prompts, right, unless they work with domain experts. So these are some of the learnings I had, where you have to really put the subject matter expert at the heart of your project, just like you did the product owner at the heart of a scrum team, right? So they are really critical, especially during the early definition phase and the eval phases. Second is that you tend to underestimate, and we all do, underestimate the work involved after you go to production, right? We all celebrate like, hey, how do you scale for production, right? Not just hardware and infra, but optimizations, uptime, support, collecting user feedback and feeding it into the optimization loop so you can actually improve the system. Without all that, your engineering work isn't delivering value. So really plan for post production. Number three, safety metrics measurement. We talked about it, the governance part a little bit, but this is worth repeating and getting deeper into. For example, how do you make sure that when you do get information out of different structures, your RAG systems, how do you ensure role-based access control? That your answer comes from sources that you actually have access to, right? What kind of eval metrics do you put in place? So at Tredence, we worked through multiple projects and we realized that it's hard to do it one by one as a custom. So we actually created something called as agentic AI lens. And we captured the core metrics that you need in terms of usage, performance, in terms of quality of responses, both RL implementations. And finally, the usage and cost, right? The token costs, the vector cost, all those things. And as we talk more about our architecture and Cosmos DB choices, you will absolutely correlate it with the performance, the quality, and the cost ROI that Cosmos DB delivers. So not forgetting about these is crucial for success in the world of AI. And the framework, creating those frameworks like AI Lens I mentioned, is really important to guide you through multiple implementations in a consistent manner.
Super. And looking ahead, what advice would you like to give this show and their teams who are basically quite keen to understand how they will stay relevant and create long-term impact over next few years. So, what is your advice here?
Manish, as we know, we are in kind of really unique times of massive change that bring big risks for organizations, also big opportunities, as we talked about. And as a leader in AI, whether you're a technical leader or a business leader or cross kind of functional leader, this is a time to really think through how to build make the right, just like a tight, aggressive, be in the game. Keep a tab on all major developments, all major ecosystem players, platform players. Where is Microsoft going, right? What are the new models doing across the ecosystem? What are the top 3 to 5 models and where they're headed in multimodality, metrics like MRCRV2, and how does this impact my implementations, right? What is happening in agentic AI protocols area, right? Who is supporting what protocols and how is it evolving? So you are kind of really ahead of the game, or at least trying to keep up, being informed. Part of that is essentially learning and trying new things out every day, every week. Number two, you have to choose which hands to play in, right? Don't get distracted. Patience and discipline are the key. And be flexible and be willing to fold fast if your chosen path isn't working. For example, if you're betting on the right tools and people who are AI native, you can double down. If you realize that the path you take is a dead end, be humble enough to say, okay, that's not where I want to throw more money in, more time in, and quickly pivot back. Finally, play to win. Absolutely. Invest decisively and execute relentlessly on the few initiatives you end up choosing. Make them successful, demonstrate value to the broader organization, right? So this tight, aggressive strategy helps you as a professional to stay relevant. It keeps you updated, sharp, and it helps you focus your limited resources, with the financial, your time, your money, your focus, and also your political capital as a leader, right, on things that matter. So finally, you can basically spin up a very virtuous cycle if you can deliver value to yourself and your organization, free up more capital, and then reinvest in the growth. So that's kind of where I would say great opportunity. Let's not hesitate. Let's make the right bets and let's make them successful.
Awesome. Thank you so much for all your uh, candid responses to my questions. And I think it's time that we should deep down and look at the solutions you have and understand how they work. I would like to welcome Ashwini, who is Director Gen AI. Ashwini, over to you.
Hey Manish, thank you. Thank you for having us here today. Hello everyone, I'm Ashwini Sharma, Director of AI at Tredence. Will introduce myself briefly. I work on building generative and agentic AI solutions that solve real business problems at scale. Uh, in recent years, I've got a chance to work extensively on vision and language models, graph-based RAG solutions, and multi-agent systems across in last more than a decade. I extensively worked in telecom analytics, business assurance, and AI transformation. I also hold a master's in artificial intelligence. where my research was focused on explainable AI and interpretable deep neural nets. So today, I, with Unmesh, will be walking through Tredence's accelerator, where we extensively use Cosmos, and we are trying to solve 6G rollout for uh, telco world. So I'll share my screen and walk that through.
Awesome. Yeah. Thanks, Ashwini. Um,
Okay.
two, one, go.
So we'll be walking you through the 6G rollout. How do we enable telecom operators to optimize the network? We have used Azure AI Foundry and Cosmos DB behind the scenes. We'll be trying to cover all the challenges, opportunity, and the solution walkthrough with the case study and quick demo. And to context setting, I'll hand it over to you, Unmesh, if you can shed some light over here, and then we'll go from there.
Sure. So we'll start with an overview of the architecture, and this is a fairly, I would say, application and domain kind of agnostic architecture. We have used it for Tredence's Atom.ai implementation across multiple industries. It is built on Azure AI Foundry and Cosmos DB. And then we'll go through a specific solution we have implemented in Telecom. Ashwini will lead us through that. We'll go through the very low-level details of implementations, and finally we'll see a cool demo where we see all of it in action. So the architecture for the modern agentic solution has three logical layers, and you can see that the value is actually shifting into the agentic, the intelligence layer, right? The UI layer is typically a web mobile application with an assistant, alerts, those kind of things. You will see some of that. But the fun part is the agentic layer, right? Here, multiple agents, AI agents are coordinating using orchestrators like LangChain, LangGraph, or Microsoft agent frameworks like Semantic Kernel, Autogen, and you may have used different kind of orchestrators in the past. And protocols like agent-to-agent protocols, agent-to-tool protocols like MCP. At the bottom of it, which is where we'll focus in the session today, is what we call as the data plane for these agents. This includes the short-term and long-term memory, all of the application data, including knowledge graphs and the embeddings and vectors. And in the past, we have always kind of looked at creating different silos for these three different kinds of piece of information, right? Where do I keep my session memory? Where do I keep my persona, user preferences, past conversations, right? And of course, how do I structure, or where do I keep my structured, unstructured data, the knowledge graphs, the documents, the key value pairs, and of course, the vectors I need for semantic searching. And the magic is that Cosmos DB actually provides a single unified data store for all of this. So you will see that we have been able to essentially use Cosmos DB as your short-term memory store to store your session context, semantic caching, and all those kind of things. We have used it for a long-term memory store where we actually maintain who you are, what you have done in the past with the application, so you get very, very contextual answers as part of Atom.ai. And then the application data, which is very unique to the domain. It can, of course, be structured, semi-structured, or as the Cosmos DB team likes to call it, the lightly structured kind of data, which could be a key value pair or a knowledge graph. So with that high-level architectural overview, let's dive deeper into the second tier of the details. Ashwini, back to you.
So before drilling deep, we wanted to explain or cover what kind of challenges and opportunities telcos face these days, and how our stack can help in those challenges. So, Unmesh, feel free to pitch in. Yeah. So, one of the aspect is slow and manual contract and document processing. So, operators can have different kind of contracts, B2B contracts, B2C contracts, sell site related contracts, and those could be scanned copies. How do we extract information and manage that information? That could be one of the challenge they are facing, because it's and generate inconsistent or different outputs from the same document, because the understanding can be different for each individual. Second could be while planning for any rollout, we check, right? So what is the coverage? The approach is always coverage first. How much area are we covering? But how do we think of revenue first coverage and decision? So where my customers with highest ROI reside. So that kind of insight. How do we think about that, or how do we solve that part? Third could be we have documentation. We know what's happening at a cell site level, but what if the documents are not up to date? And it requires a physical assessment to a human to go and look at that site and see what exactly has been installed, how many mounts are there, how many are utilized, how many are free. How do we automate that piece? So another opportunity comes from there. And finally, the fragmented data. So we are talking about contracts, we are talking about revenue data which is residing in BSS, OSS, some kind of structured form. Third, we are talking about human assessment of a physical location, and they reside in different systems. So BSS, OSS, unstructured data, structured data. How do we give a single view, a unified view? And on top of it, how do we retain this tribal knowledge? Each SME in each field might be having. So BSS, OSS experts, the document experts, the contract or legal experts, or the site assessment experts. So how do we combine all the information?
Yeah, that's really well said. And at Tredence, we are actually working with two of the top 3 to 4 telecom operators in North America. We are doing multiple projects in Europe and quite a few in Middle East in the last couple of years, especially. And we have noticed that these challenges are a repeated pattern. A lot of times there is a specific process which is focused on network, and then there is a complete financial analysis done separately. And our solutions are essentially integrating it into an outcomes first, revenue first, margin first approach to, for example, network rollout or decommissioning of your old network equipment. So you are actually investing where your ARPU is, where your customers are, where the growth is, right? And you are absolutely accelerating the decision-making process by having the right information at your fingertips at the right time.
Thank you for adding that, Unmesh. I'll move forward.
Yeah.
To you, Unmesh, if you want to shed a
Let me
light
give a
on the
quick
overall.
overview. So this is a really good example of how the telco Atom.ai has actually materialized in what we call as a project Zenith. This is our end-to-end solution designed to transform network planning, network strategy, network rollout into a fully revenue-led cost optimized strategy that I mentioned earlier, right? It is built around very tightly integrating the modules that are mentioned here. There is obviously a proven savings engine. So if you look at the application, this is in the US geography, but we have done something very, very similar globally, where at the heart of it, on the left-hand side, you will see all the key performance metrics right at your fingertips. This is not a traditional dashboard. These are agents running in the background, proactively collecting metrics. Some could be last minute, some could be a week old, some could be a month or a quarter old, right? But you are actually collecting those metrics through autonomous or semi-autonomous agentic processes, and then rendering it on top of your network topology, on top of the geographical view that you want to see in terms of which markets you are in, or metropolitan areas you are operating in. And then on the right hand side, the systems are smart enough to also watch out for things that you are interested in keeping a tab on. So, for example, what's happening in my network? Is there an outage, right? Am I behind or ahead in terms of my cycle time for plans? And all of those things you can see in terms of concrete metrics: number of dollars saved, potential increased revenue, number of delays in time, essentially improve productivity and efficiency numbers. And you can drill down by specific state, specific region, or specific technical area.
Thank you. So before going to the architecture, a quick glance to the Zenith, the overall solution. So there are three core modules to it. Module A is the challenges or opportunities we just talked about, right? So one is strategic sell-side contract engine. How do we extract information and build reasoning on top of it, on top of those contracts? How do we parse? And here we pitch in Atom.ai, which is our intelligent document processing accelerator. So we use Atom.ai for parsing, then reasoning engines to agentic reasoning engines to do the redundancy detection. So we want to roll out 6G, which 5G sites will be redundant after that? And can we do negotiations on some of the contracts? Second module, not only this unstructured data, we would need to use the revenue data from our current OSS BSS system. How do we make use of it? How do we go from coverage heat map to revenue heat map? And module C is if the documentation or the information is not latest and greatest, how do we capture the cell site information? What kind of hardware, what kind of modules, what kind of remote radio units or baseband units are available or not? So using the drone, zero-touch drone surveys to eliminate the physical review cost or a manual survey cost. So moving ahead with this picture in mind, three modules, Atom.ai for parsing or intelligent document parsing. We present this overall solution which we have built on top of Azure. So we have our multimodal data sets. So it can be a contract, which is a PDF, or we can have our OSS BSS data from some database or apps, and then we can have drone footage as well. So at the second layer, where we are talking about extraction and ingestion, we have used our accelerator Atom.ai built on top of Azure using Azure Foundry models and Data Factory, which does parsing, OCR, extraction, understanding the audio and video as well, does classification, extract the information and pushes it to our storage layer, which is Cosmos. So here we are using SQL data and NoSQL plus Gremlin, both the APIs in Cosmos. So we want to get the unstructured data, make some meaning out of it, or structured information, maybe fields, maybe clauses, maybe verbatim text, and we store that in Cosmos as NoSQL, or we create a graph on top of it. So not only storing those data, we are using this for our agents, memory, vectors, search indices, and short and long-term memory, as Unmesh mentioned earlier. So on top of it, so now we have extracted the information stored in Cosmos. On top of it, how do we build the decision intelligence, the three modules which we just talked about? How do we get insights from the data? How do we merge all three siloed information? So we have our deep research agents sitting on top of it, following some orchestrator and worker concept. So we have our module A, contract engine, module B, revenue propagation, and drone surveys. All the agents sitting on agentic layer to make the decision built on decision intelligence. We are using Microsoft Agent Framework over there. And Unmesh, if you want to add some more information on the agentic layer, would be great.
Yeah, what we have done is created a very easily composable architecture where a lot of the common capabilities are created as intent specific subagents. So there is, as you see in this picture, an intent specific subagent which does, let's say, drone surveys, right? And for drone surveys, you might actually need to analyze a bunch of pictures. So that is probably a subagent. And then every use case is created as an orchestrator. It has the idea of what your subject matter expert, the domain expert, is looking for, and it orchestrates to the right subagent. For example, it might go and look at your unstructured content with pictures, then your structured content, or maybe it looks at your contract. Do I have access to this site? Right? Do I then, it might go analyze pictures and find out the relevant information. It might update a structured or an unstructured database with the latest information to make sure that your data in the system of records is actually matching the real information on the site as you do those surveys, right? So every use case, think of it as an orchestrator that reuses a lot of existing subagents. So over a period of time, your cost of building new use cases is going down quite a bit, and you're also amortizing a lot of existing infrastructure, existing agents that you have built in the past.
Thank you, Umesh. So now we have our data sources, information is extracted. We'll touch upon Atom.ai in detail because we wanted to talk about intelligent document processing. But right now we are giving the overall scope of Zenith. And then we have an agentic layer. And on top of it, we can expose some of the APIs. We have exposed these agentic APIs and a consumption layer. Won't go in depth over there, but yes, we have used Azure end-to-end over here. Moving forward, wanted to talk about Atom.ai, which is our intelligent document processing, which uses agentic AI at its core. So we'll have the architecture in the next slide. So we wanted to cover what core capabilities and what kind of use cases we can build on top of Atom.ai. So it has multimodal capabilities, as you have seen. So we can extract not only text, but if the document is scanned images, we can extract text with bounding boxes and the visual grounding, information from the charts, from the tables, spread across pages, context spread across pages in a single pipeline. And the precision is legal grade. Sometimes we don't want to generate, we want to extract verbatim as it is, because these are legal documents. So no paraphrasing for legal documents. And with the confidence scoring of extraction. And on top of, yes, Umesh.
Sorry to interrupt, but I was going to refer to some of the projects where we have actually extracted information from documents that were scanned 20 years back, right? So the scanning quality is absolutely not quite there. And Ashwini and I have a lot of battle scars from those experiences where it was humanly impossible to actually make sense of those scanned documents, and they were 75-page documents with very bad scanning quality. Some pages could be upside down, and to be able to extract that level of unstructured content, which is not really high quality data, and has multiple modalities, images, charts, tables, which are really not readable clearly. Building those pipelines was very, very interesting, and it takes multiple iterations. The benefit for our customers is that they don't have to go through these iterations. They get to directly tap into our experience and our past attempts of building it and experience of actually making it work. But now, actually, back to
Yeah.
natural
Yeah.
language query part.
Yeah, that was a great example because I remember one was more than 20 years, and yeah, I still remember that document. So thank you for adding that. Uh, so so now so two key aspects I wanted to cover here. So maybe two key takeaways. So the extraction is one piece, but how do we store what all we extract? Not only the text, but we can build on top of that. So we don't, in case we want any specific information from that document, that could be a legal clause or a specific field to make a decision, or we need to summarize as well. So not only extraction, we can build customized template, what kind of output is required accordingly. And the the distinctive feature is smart backfill. I would like to emphasize over there. If we are doing a human evaluation and we miss something while doing extraction, a human or as an SME was doing an extraction and miss something, we have to go through that document again. But with this, we can easily do the backfills. If you want to add a new field in future, let's say 10 years after today, oh, we missed that information. We have to go back and add that information. So we can smart backfill is possible now. And on top of it, we can talk in natural language. We can ask in a natural language, get a response. So text to SQL or text to Gremlin, everything is handled behind the scenes. And we can extract information from contracts. We can extract information from financial documents, equipment guides, version controlled equipment documentation for radio antennas, contact center analytics, and any legal insights which you are looking for, any B2B or B2C contracts as well. So there can be multiple use cases on top of it. And if we go in depth, so the documents as an input, we can handle pre-processing, we can do version control, change capture, metadata, and then the actual extraction agents, which are working, which are using vision language models and reasoning models behind the scenes. We can do OCR plus layout, table structure, everything can be captured. On top of it, we can build visual grounding, the confidence score. We are using Azure AI Foundry for that, the multimodals over there. So once we have extracted, we can have a layer which can do auto evaluations as well. So if we have some ground truth, how do we reason with that data? So this is the extraction data with 90% confidence score, and this is the extracted and this is the expected. So what kind of confidence score it should have been, 99 or 70? So we can have a separate reasoning engine on top of extracted information, and we can plan, we can cross validate. So if we are talking about one document here, we can do cross validation across documents, we can do cross validation across entities, and we can aggregate the insights. So as I mentioned in last one, the output templates can be different. You need a field or you need a verbatim clause, both are possible. On top of it, we can have human in the loop as well, and everything goes. Everything goes to Cosmos. We can use the documents, we can use the key fields, the verbatim extraction, we can generate and store embeddings, we can do semantic search on top of it. And if we need some kind of entities and events or from extracted from those contracts, that is also possible. We can use Cosmos Gremlin API to create what he says an agent as edges and store them and do the traversal on top of the graph. So all the agents, their memories, long-term, short-term, both, everything is sitting in Cosmos again. Some of are summarized and vectorized as well for easy retrieval, and we are enabling our tracing as well. So logs and traces are also there. So what happened, we can go point in time and see what has happened on that time. So it's just not a single pipeline. Yeah,
That part is very critical, especially in large enterprise scenarios. We found that explainability, right? Why was certain decision taken? Why did agents take a particular path? Which tools they called? Did they actually call all the right tools, right? Those kind of guardrails and explainability were actually very, very critical. And what I would like to add is that the Microsoft AI Foundry, and the names have been changing, right? Azure AI Foundry, Microsoft Foundry, has been a great platform for bringing all these capabilities together, right? From data ingestion to kind of basically run as a control plane, which is fairly self-managed, right? You don't have to actually do a lot of management yourself in terms of the runtime, the scaling, and the connections to all your backend systems. The availability of a wide variety of multimodal models, as Ashwini explained, there are models that you need for vision, obviously text and images, audio, sometimes transcription, the variety of models that are available in Azure AI today is phenomenal. So the ability to put it all together very, very rapidly, roll it out as a POC, and then take it to scale, improve the accuracy to 90-95% plus, makes it a big challenge. But Azure AI Foundry made it fairly easy on the control plane side. And then, of course, Cosmos DB being a single unified data store across all these varieties of content, structured, semi-structured, lightly structured, in one single place. And the ability to go search using kind of semi-structured queries like Gremlin APIs, or do like fuzzy and semantic searches on top of your data inside Cosmos DB, made it the kind of right choices for both the agentic control plane as well as the data plane for our agentic AI applications.
Yep. Or do a hybrid query in a very SQL-like comfortable where clause, where you do both hybrid and vector. So that's a great feature Cosmos is providing to us. So till now we have discussed about the project Zenith, different challenges which we are trying to solve. Then how do we extract information from documents, structured documents, that's agentic intelligent document processing. And so module A was how do we build on top of that those contracts. Module B was revenue, and module C was drone. Now how do we put everything together? So I'll take module C out of the picture because that's a video pipeline where we extract information and identify. But at least module A and B, how do we stitch everything together? So now we have Zenith, now we have Atom, and this is a unified way how we have used it in our network optimization use case or project. So how Cosmos powers this multimodal intelligence. And so in module A, we are using, so documents are coming in, the contracts are coming in. We are using atom.ai to extract information, layout-based extraction, and then visual grounding on that raw text, and finally, maybe some fields or clause extraction and verbatim extraction. Everything being stored in Cosmos DB for NoSQL, where a user can interact in a simple SQL-like syntax, SQL language. So here we have tags, fields, the Atom agent's memory, which we just talked about, the logs, the explainability of extraction. Second part, we go to the core of telecom, where we have OSS and BSS. So the billing system, the price plans, which customers are using, are on the high ROI plans, what is the cell site utilization, what is the coverage area map, which cell sites are there in which geolocation, the lat and long, and what is the radius of that. So those kind of information is coming from BSS and OSS, the churn details, the cell site details, the complaint details, everything. Now, how do we put everything together, right? So we are saying things are siloed, but how do we put everything together? So we extracted information, created vectors, got the verbatim, got the fields, everything is good. We are in Cosmos. Then we are using SQL and Cosmos again for OSS and BSS data. Now the revenue signals are being merged with the extracted contract terms to give an overall picture. So not only for this sell side, what are my legal rights, plus what are other key terms, what how many antennas I have, then what is the lat long, what is the radius, what is the load on this side, the usage details, and in this area, which kind of customers reside. Are they high paying customers, or it is not an ROI friendly site? So that intelligence is there, and on top of it, Cosmos gives us feasibility to create graph. So we have built uh, in module A and module B. So module B takes all of the data, creates the graph entities and relationship between that graph, and store in the same familiar interface, which is Cosmos with Gremlin API. So now we have NoSQL where we are storing JSON, and on the same time we are storing our indexes and our entities and relationship as well, and it gives us end-to-end picture. So now we can have a country which has multiple locations, and those locations can have multiple cell sites. Those cell sites can have details not only from the documents but also from your BSS and OSS systems. So a unified view at one place. And what are some benefits over Cosmos? Unmesh can shed some light over there, but we have mostly covered these pointers.
Yeah, let me just quickly highlight a couple of things. This is good information for our audience to go through in detail. But two main things that we haven't covered enough probably is global scale, global replication. Now you can actually have regions, multiple regions, and then very rapid replication of that data. So you get consistency. Talking of consistency, we have always had strong and eventual consistency, but Cosmos DB has three more consistency levels. So you can actually decide how much of consistency, what strength of consistency you want and how much you want to take over on the application side. So you can actually adjust accordingly. The ability to handle very, very high level of IOPS, queries and rapidly respond. And then all of it kind of really being managed, right? Being able to horizontally scale in and out. Depending on when you start, you may have a few RUs, the unit of consumption, and scale up and down pretty rapidly depending on your load. So it becomes much more easy where you are focused on the business outcome, the actual problem you're solving, and less worried about how to implement scale, how to actually implement consistency, and how to worry about not having to worry about the performance of the database itself has been a massive benefit through Cosmos DB.
Thank you, Ramesh. We have a use case, a case study from one of the customers. If you
Yeah, let's talk
add
about
something
that.
about
So the proof of pudding is in the eating, right? So here is a really good customer case study that we have implemented Zenith and Atom.ai in. This is one of the largest telecom operators in the North America region, and obviously they are doing multiple rollouts, spending billions of dollars, and they are trying to very tightly manage their cost and drive efficiencies. So the core problem here was how to extract insights and use those insights to make business decisions. The challenge, you have hundreds of thousands, actually a couple of million documents with very complex legal contracts, and they were spending millions of dollars, probably tens of millions of dollars in legal paralegal cost every time they wanted to change something. Every time the lease comes up for renewal, or you want to go change something, you have to go look up entitlement rights, and this actually costs and slows down your business, right? So how do you actually take care of these manual processes and help decision makers was the challenge that was given to us. worked very, very closely with the Microsoft team. Microsoft team helped us with some of the early POCs, the customer, and then we helped with scale. This is a very standard pattern where Microsoft works with partners like Tredence to implement. The solution was effectively a multi-layer abstraction from taking, number one, extracted content from these contract documents, so the complete pipelines, extraction, and then take those key fields, the clauses and subclauses, and tie it down to decision-making hierarchy. Number two, you actually take all of these pipelines, the data pieces, information extracted, and create a knowledge graph that represents the entities and relationships in your business world, right? With advanced storage, with ability to search through Gremlin APIs, as Ashwini explained, but also to do semantic searches. So if the user is asking for a particular vendor with whom I am actually leasing the droning equipment or a particular macro site, I don't have to remember the exact spelling. It's not a SQL. It's a fuzzy match, right? And then also a lot of auto triggering. When are your next contract renewals due? How can you actually negotiate a better contract based on market data, based on trends, and based on many other third-party piece of information that we were able to bring into Cosmos DB and into the decisioning layer, which was implemented as a set of agents. Outcome, we are able to currently deliver about 80% time savings in terms of ability to gather information. So if it was taking 2 months to make a decision, now it's 1 to 2 weeks. And we are able to, or the customer is able to much faster collect all the information, connect it, and then make business decision. This is translating into probably $10+ million of cost savings. Those savings to be in multiple tens of billions of dollars per year. Massive, early but massive success, indicating how such a solution can help telcos across the world.
Thank you. So now, before a quick short demo, putting the whole picture together, I'll reiterate, we have Zenith, which has 3 modules. Out of those 3 modules, let's say Atom.ai is helping us to extract information, and then that information is merged and joined with OSS BSS information. So let's say we have 5G cell sites and we want to go for 6G rollout, right? So if we are putting these 20 or 30 or 40 6G sites, will it make some of the 5G sites redundant? And we can remove those, or we can save some money over there, because the contracts will tell us, right? We are paying this much OPEX for those sites. So CapEx is one aspect of 6G, but OPEX of those 5G cell sites where we are paying for electricity, some rent, some cables, and the manual assessment and the fixing of any breakdowns, and maybe generators, gas, whatever, whatnot. So all the OPEX, if we retire some of these sites, we can save some money on OPEX. How do we do that? So that's the hypothesis, that we can save 20 to 30% on these high-cost legacy metro sites. And we are talking about any big metros core area. So we have taken a case study for Dallas, where we have generated synthetic data. Let's say 80 sites are there in the dense core. And after we have done 6G planning, and due to 6G densification, 35%, 28 cell sites became redundant. And the average OPEX cost we could save is 88.5K per year. The annual savings would be 2.48. And if we go At national level, it could be 50 to 100 millions. And some reference calculations are also put over here. You wanted to add something, Unmesh?
Yep. No, this is a real, real case of how we can save hundreds of millions of dollars. Maybe we can bring up the, Cosmos DB and interface and actually show some of the nodes, edges, and how we actually work on this.
Yes. Yes, definitely. Just some questions I wanted to highlight. What kind of questions we can answer? So we can have contract intelligence. How many macro sites are redundant due to 6G? But how all this is happening? Because we have contract data, we know lat longs, we know how much we are paying for those sites. We know because of BSS and OSS, are they highly utilized? Are they dense? If the ROI is high, what is the radius of that site? So those all things after Zenith, we were able to understand at one place. And we have created not only entity in the relationship. So first, I would like to give a view where how can we do it in Cosmos itself, the NoSQL interface itself. If we are able to create JSONs and store there, and we can use filters to extract the information, that will save some RUs. And if the relationship is so complex that we need traversal, then we can go ahead and create graphs in using Gremlin API. So I'll quickly, and this is familiar one now because Unmesh just talked about this one initially. So this is how the UI looks like, but I wanted to jump directly to Cosmos.
Yeah, while you bring that up, there is actually an agentic interactive assistant that we have built where you can ask those questions. And today we want to show how this actually works when you go to the underlying data plane. So we are focusing on the Cosmos DB part of the Azure services, but the user experience is definitely a natural language interactive assistant.
Okay. So hope you can see my
Yes.
Microsoft Azure account.
Yep.
Okay. So in the resources, you can see we have two resources created. One is for the NoSQL and one is with the Gremlin API. If we see, hope this is familiar, looks familiar, the Data Explorer over here. We have a database contracts v2 where we have a container contract rationalization. So we have extracted information. I'm reiterating, bear with me. We have extracted information from contracts. We have married that data with BSS OSS data and how the data looks like those. And on top of it, there were module A and B's deep research agent, which were talking to each other, doing reasoning in a self iterative refinement loop, and came up with this information. So where we have country, state, operating region, we have a location with lat long, we have cell sites, the address, the contracts for that cell site, the details of those contracts, the status, dates, terms, everything extracted, the hardware details, the radio unit details, what vendors, legal clauses, the site profile. Now again, BSS OS. So annual OPEX is there, technology is there. From OSS site manuals, we have all the information as well over there. This information we can query to answer these kind of questions. Let's say, how many macro sites are redundant due to 6G coverage? And what is the total annual savings if we terminate them? We can create SQL query in this NoSQL data store and get the answer. So number of sites with the annual savings 2.48, a familiar number which I have just shown. And let's say how many sites are coming up for a renewal or going to expire in next and near term. So there are 25. The other question could be from an SME would be, oh, they are expiring. Do I need to renew or no? If they are redundant and they have empty slots for antenna mounts, I might need to keep them. Are there any sites which have this kind of configuration where are coming not near expiry, but yeah, so there are some sites they are not near expiry, but we can put 6G antennas over there. So one is if something is coming nearing expiry, do I renew or no? The other aspect could be if there some things are long term, they are not coming near expiry, can I repurpose those? If there is available mount. So yes, there are some sites, these three sites with available mounts, we can put our 6G antenna over there. So there can be multiple domain specific questions from SMEs which can be answered now. So
I would like
multiple.
to add that a lot of these queries are dynamically generated based on user question. The agents are intelligent enough to understand the user's intent, the entities they actually refer to, for example, like a particular location like Dallas, generate or pick the right kind of queries and then execute the query, convert it back into natural language, and present it as an answer in English or other language if you prefer. Okay, you also saw that you there was a cost saving of about 24.9 2.5 nationally or to whatever geographies you are analyzing.
What if the relationship is complex and we are not able to answer using plain filters in Cosmos, right? We have multiple sites which are the nearby sites, or let's say my electricity vendor is Encore, and how many sites are being powered by Encore? So that is a complex relationship. We don't want to keep using the filters over there. So Cosmos gives a very good view over there. So we have ingested some of the 5Gs over here. This is the Gremlin interface. If you see, I'm not sure how good you can see on this screen.
Yep.
Let me visualize.
Yep.
So this is a specific Dallas metro example where we have a country which can have different state. Each state can have different cities. Dallas has Dallas also have like core, which is Dallas city, and the suburbs like Irving and some others, Plano Frisco, some other cities. And this city has, let's say, 80 sites, and out of those 10 you can see right away. And if you want to see the properties of these, so yeah, you can see USA, what is the site, latitude, longitude, the kind of site. So those site level details, you can see cell site level. Details also. And on, if you want to go to specifics, let's say what all contracts were there at this site and what are the details on those contracts. So remember atom.ai, where we were extracting details of those sites, what document, what are the file name, when it was executed, what are the status of the contract, the rents, escalations and renewals, what kind of equipments are placed over there, who are the vendors, and some other information. So it can be a key or a text, a verbatim text, or a legal clause, everything at one place, and gives you a very good visual representation. And let's say there are 50 states, and each state can have, and then you need to traverse, you need to go cross cities, you want to go different state because one vendor is giving you services across states. Those kind of questions can be answered easily after that.
Yes, wonderful. I hope this demo was useful for our audience. Feel free to reach out to us at as part of the Microsoft Cosmos DB team if you have any other questions related to Microsoft Cosmos DB or AI Foundry, but definitely to us at Tredence team. You will have the links. If you have any questions about Zenith AI or Atom.ai or solutions which are actually cross-industry as well as specific solutions for telco, media, and technology industry. Back to you, Manish.
Thank you so much, Unmesh and Ashwini. It was really nice presentation and demo. Uh, with that, we would like to move to the next section of the show. Thank you so much, Unmesh and Ashwini, for your time.
Thank you.
Thank you.
Um, what is happening with Cosmos DB? Latest announcement we have is that we are now having Cosmos DB mirroring in Microsoft Fabric with private endpoint. The benefit of this is basically that if you already have Cosmos DB behind the Power Private endpoint, you can easily add the Fabric IDs with Cosmos DB and have a secure copy of the data to Fabric. So this is was there as a public preview in Jan, and this time it is gone live, so you can try out with all of your production environment. So this is I'll share the marketplace link of Tredence, the solutions they have presented. If you have any questions, please feel free to submit onto the comment box below, and we'll be happy to address any questions. And next session we're going to have is on 30th April. It will be an exciting session. Till then, goodbye, see ya, and keep learning and keep growing. Thank you. And if you have, by the way, if you have any interesting story, you are a partner yourself, please feel free to reach us out, and we'll be happy to capture your story. Thank you so much. Bye bye.